Sawdust. Sawdust or wood dust is a byproduct or waste product of woodworking operations such as sawing, sanding, milling, planing, and routing. It is composed of small chippings of wood. These operations can be performed by woodworking machinery, portable power tools, or by use of hand tools. Wood dust is also the byproduct of certain animals, birds, and insects which live in wood, such as the woodpecker and carpenter ant. In some manufacturing industries, it can be a significant fire hazard and source of occupational dust exposure. Sawdust as particulates is the main component of particleboard. Research on health hazards comes from the field of occupational safety and health, and study of ventilation happens in indoor air quality engineering. Formation. Two waste products, dust and chips, form at the working surface during woodworking operations such as sawing, milling, and sanding. These operations both shatter lignified wood cells and break out whole cells and groups of cells. Shattering of wood cells creates dust, while breaking out of whole groups of wood cells creates chips. The more cell shattering that occurs, the finer the dust particles that are produced. For example, sawing and milling are mixed cell shattering and chip forming processes, whereas sanding is almost exclusively cell shattering. Uses. A major use of sawdust is for particleboard. Coarse sawdust may be used for wood pulp. Sawdust has a variety of other practical uses, including serving as a mulch, as an alternative to clay cat litter, or as a fuel. Until the advent of refrigeration, it was often used in ice houses to keep ice frozen during the summer. It has been used in artistic displays and as scatter in miniature railroad and other models. It is also sometimes used to soak up liquid spills, allowing the spill to be easily collected or swept aside. As such, it was formerly common on barroom floors. It is used to make cutler's resin. Mixed with water and frozen, it forms picrete, a slow-melting, much stronger form of ice. Sawdust is used in the manufacture of charcoal briquettes. The claim for invention of the first commercial charcoal briquettes goes to Henry Ford, who created them from the wood scraps and sawdust produced by his automobile factory. Food. Cellulose, fiber starch that is indigestible to humans and a filler in some low-calorie foods, can be and is made from sawdust, as well as from other plant sources. While there is no documentation for the persistent rumor, based upon Upton Sinclair's novel The Jungle, that sawdust was used as a filler in sausage, cellulose derived from sawdust was and is used for sausage casings. Sawdust-derived cellulose has also been used as a filler in bread. When cereals were scarce, sawdust was sometimes an ingredient in Kommissbrot. Auschwitz concentration camp survivor Dr. Miklos Niesli reports in Auschwitz, a doctor's eyewitness account, that the subaltern medical staff, who served Dr. Joseph Mengele, subsisted on bread made from wild chestnuts sprinkled with sawdust. Health hazards. Explosions and fire. Sawdust is flammable and accumulations provide a ready source of fuel. Airborne sawdust can be ignited by sparks or even heat accumulation and result in explosions. Environmental effects. At sawmills, unless reprocessed into particleboard, burned in a sawdust burner, or used to make heat for other milling operations, sawdust may collect in piles and add harmful leachates into local water systems, creating an environmental hazard. This has placed small sawyers and environmental agencies in a deadlock. Questions about the science behind the determination of sawdust being an environmental hazard remain for sawmill operators, though this is mainly with finer particles, who compare wood residuals to dead trees in a forest. Technical advisors have reviewed some of the environmental studies, but say most lack standardized methodology or evidence of a direct impact on wildlife. They don't take into account large drainage areas, so the amount of material that is getting into the water from the site in relation to the total drainage area is minuscule. Other scientists have a different view, saying the dilution is the solution to pollution argument is no longer accepted in environmental science. The decomposition of a tree in a forest is similar to the impact of sawdust, but the difference is of scale. Sawmills may be storing thousands of cubic meters of wood residues in one place, so the issue becomes one of concentration. But of larger concern are substances such as lignins and fatty acids that protect trees from predators while they are alive, but can leach into water and poison wildlife. Those types of things remain in the tree and, as the tree decays, they slowly are broken down. But when sawyers are processing a large volume of wood and large concentrations of these materials permeate into the runoff, the toxicity they cause is harmful to a broad range of organisms. Wood flour or flour. Wood flour is finely pulverized wood that has a consistency fairly equal to sand or sawdust, but can vary considerably, with particles ranging in dimensions from a fine powder to roughly that of a grain of rice. Most wood flour manufacturers are able to create batches of wood flour that have the same consistency throughout. All high-quality wood flour is made from hardwoods because of its durability and strength. Very low-grade wood flour is occasionally made from sapless softwoods such as pine or fir. Applications. Wood flour is commonly used as a filler in thermosetting resins such as bakelite and in linoleum floor coverings. Wood flour is also the main ingredient in wood/plastic composite building products such as decks and roofs. Prior to 1920, wood flour was used as the filler in 1/4-inch thick Edison diamond discs. Wood flour has found a use in plugging small through-wall holes in leaking main condenser heat exchanger tubes at electrical power generating stations via injecting small quantities of the wood flour into the cooling water supply. Some of the injected wood flour clogs the small holes while the remainder exits the station in a relatively environmentally benign fashion. Because of its absorbent properties, it has been used as a cleaning agent for removing grease or oil in various occupations. It has also been noted for its ability to remove lead contamination from water. Wood flour can be used as a binder in grain filler compounds. Transpirable particulates. As with all airborne particulates, wood dust particle sizes are classified with regard to effect on the human respiratory system. For this classification, the unit for measurement of particle sizes is the micrometer or micron mm, where 1 micrometer equals 1 micron. Particles below 50 mm are not normally visible to the naked human eye. Particles of concern for human respiratory health are those 100 mm where the symbol means less than. James 2004 has defined the size of indoor particulates according to respiratory fraction. Particles which precipitate in the vicinity of the mouth and eyes and get into the organism are defined as the inhalable fraction, that is total dust. Smaller fractions penetrating into the non-cartilage respiratory tract are defined as respirable dust. Dust emitted in the wood industry is characterized by the dimensional disintegration of particles up to 5 mm, and that is why they precipitate mostly in the nasal cavity, increasing the risk of cancer of the upper respiratory tract. Exposure. The parameter most commonly used to characterize exposures to wood dust in air is total wood dust concentration in mass per unit volume. In countries that use the metric system, this is usually measured in mg/m3 mg per cubic meter, a study to estimate occupational exposure to inhalable wood dust by country, industry, the level of exposure and type of wood dust in 25 member states of the European Union, EU-25 found that in 2000-2003, the highest exposure levels were estimated to occur in the construction sector and furniture industry. Cancer. Wood dust is known to be a human carcinogen, based on sufficient evidence of carcinogenicity from studies in humans. It has been demonstrated through human epidemiologic studies that exposure to wood dust increases the occurrence of cancer of the nose, nasal cavities, and paranasal sinuses. An association of wood dust exposure and cancers of the nose has been observed in numerous case reports, cohort studies, and case control studies specifically addressing nasal cancer. Ventilation. To lower the concentration of airborne dust concentrations during woodworking, dust extraction systems are used. These can be divided into two types. The first are local exhaust ventilation systems. The second are room ventilation systems. Use of personal respirators, a form of personal protective equipment, can also isolate workers from dust. Local exhaust. Local exhaust ventilation (LEV) systems rely on air pulled with a suction force through piping systems from the point of dust formation to a waste disposal unit. They consist of four elements: dust hoods at the point of dust formation, ventilation ducts, an air cleaning device, waste separator or dust collector. The air containing dust and chips from the woodworking operation is sucked by an impeller. The impeller is usually built into or placed close to the waste disposal unit or dust collector. Guidelines of performance for woodworking LEV systems exist, and these tie into occupational air quality regulations that exist in many countries. The LEV guidelines often referred to are those set by the ASAIA. Low volume/high velocity. Room. If suitably designed, general ventilation can also be used as a control of airborne dust. General ventilation can often help reduce skin and clothing contamination and dust deposition on surfaces.